The eviction queue manages memory reclamation across the buffer substrate when available heap space falls below the configured threshold. The queue operates as a priority deck, processing candidate pages according to their access cost estimate and resident duration. Eviction candidates are selected from a global pool maintained by the reference tracker, which monitors all allocated page references in real time. The selection algorithm does not interrupt active transactions. Access cost estimation relies on a sliding window of reference counts sampled at fixed intervals. Each page maintains an internal histogram of access patterns divided into 5-minute buckets. Pages with 0 references in the current window receive a base cost score of 0. Pages with references in the previous window receive a decay multiplier of 0.7. The histogram is cleared when a page reaches age threshold or is explicitly flushed to persistent storage. Resident duration tracking begins at allocation time with a timestamp stored in the page metadata header. Duration is calculated as elapsed time between current system clock and the original allocation timestamp. Pages resident for longer than 3,600 seconds receive a duration priority boost. This boost increases the eviction candidate's score by a factor proportional to how far the page exceeds the threshold. The boost prevents indefinite retention of unused but recently allocated pages. The victim selection phase iterates through the eviction queue in priority order, evaluating each candidate against a set of retention constraints. Pages participating in active transactions are skipped immediately without evaluation. Pages with dirty flags set cannot be evicted unless the write-back subsystem has scheduled a flush operation. Hint pages, those held by session cursors or temporary indexes, remain ineligible until all session references are released. Once a victim page is selected, the eviction sequence begins with a constraint verification pass. The system checks whether the page holds any uncommitted modifications by examining the transaction log timestamp. If modifications exist and the transaction is still open, the candidate is deferred and the next page in the queue is evaluated. If modifications have been committed, the write-back scheduler is invoked to persist the page to disk before removal. The write-back operation for a victim page follows standard checkpoint protocol. The page data is serialized to the designated buffer sink, typically a memory-mapped file or network socket depending on the storage backend configuration. A write acknowledgement token is recorded in the event log. Once the acknowledgement is persisted, the page is removed from the in-memory buffer pool and its allocated memory is returned to the heap allocator. Clean pages, those with no uncommitted modifications, proceed directly to eviction without write-back delay. The system marks the page with a removal flag and updates the global page directory. The page entry is removed from the buffer hash table, making the allocation invisible to subsequent lookup queries. If future access to the evicted page is required, it will be fetched again from persistent storage into a new page slot. Memory deallocation for evicted pages occurs in batches to reduce fragmentation impact. When 10 or more pages have been marked for removal, the allocator performs a consolidation pass. This pass merges adjacent free blocks in the heap and updates the free list structure. The consolidation process updates internal heap statistics but does not perform full compaction, which would halt all user queries. The eviction queue is continuously refilled as new pages are allocated and reference patterns change. A background thread executes every 30 seconds to recalculate priority scores for all pages currently in memory. This thread has lower scheduler priority than user query threads, ensuring interactive workloads are not delayed. The scoring thread completes within a fixed time budget of 1 second per invocation. Emergency eviction mode activates when available heap space drops below 5% of configured maximum. In this state, the victim selection algorithm becomes more aggressive, skipping cost evaluation and selecting candidates by resident duration alone. Pinned and transaction active constraints remain enforced, but access cost and decay factors are ignored. Emergency mode continues until available space recovers above 10% threshold. The eviction metric subsystem tracks all victim selection decisions and maintains historical statistics. Counters record the total number of evicted pages, pages evicted in emergency mode, and pages that failed eviction due to constraint violations. These metrics are exposed through the monitoring interface at configurable intervals. High rates of failed eviction attempts typically indicate persistent transaction hold times or undersized buffer pool allocation. Configuration of eviction behavior is available through the system settings table. The parameter eviction queue depth sets the maximum number of candidates pre-evaluated during each scoring cycle. The parameter eviction batch size controls how many pages are processed before releasing control back to the scheduler. The parameter emergency threshold % defines the heap usage level that triggers aggressive selection mode. Access patterns that cause repeated eviction and reallocation of the same pages are termed thrashing events. These events indicate that the buffer pool size is insufficient for the working set. When thrashing is detected by monitoring the reallocation rate, the system logs a warning message and can optionally pause eviction until the working set stabilizes. Administrators should increase buffer pool size if warnings appear consistently. Page size impacts eviction efficiency significantly. Larger pages result in fewer total pages in memory, but increase the cost of evicting a page with partial utility. Smaller pages provide finer granularity but increase overhead in queue management and metadata tracking. The default page size is 8,192 bytes, balancing these trade-offs for typical database workloads. Custom page sizes must be set at initialization time. The eviction subsystem interacts with the write-back buffer scheduler to coordinate I/O operations. When multiple pages are queued for eviction, the scheduler attempts to batch writes to sequential disk locations. This batching reduces seek time and improves throughput. If the write-back queue becomes full, eviction is throttled until the scheduler completes pending operations. Eviction queue processing is essential for maintaining system stability under varying workload conditions. The subsystem automatically adapts selection priorities in response to memory pressure, while enforcing transaction consistency constraints. Monitoring and tuning eviction parameters should be part of regular system maintenance procedures. Detailed logs of eviction events are available in debug mode for troubleshooting memory allocation issues.